Well, last week you did what? You did the student info sheet, algebraic proofs. This is going in the grade book potentially today. Okay, so y'all know that first assignment on 813, number 1 through 5. That digital one, a lot of people had trouble with it. It's kind of sketchy, so I don't know if we're going to count it. We'll see. I should, right? I should, right? Oh, okay. Well, all right. Maybe I won't. Maybe I'll do this. Watch. Oh, dang. Thank you. I'm slapping. Wait, still frozen. Now, we'll have a quiz, not this week, but next week, I believe. Okay. So, if you did not turn to last week's warm up, make sure you do that. And then let's do this warm up. Ready? Can you solve? By the way, you're supposed to be proving that x equals -2, not positive. My bad. All right, so here we go. X is on, by the way, if you're trying to prove something, your first step is to just rewrite it. And what's the reason? Given. So everybody, you already should have tried to solve this, right? Your original step is writing it down. You know it's given, so you say given. Now look, X can only be on here once, so I see two X's. That means I either have to combine them or get rid of one. What do you think I should do? Okay, can't be on both sides of the equals, so yeah, get rid of the smaller one is what I say. How do I get rid of a positive 2x? Negative or minus 2x. Now careful here. What do I bring down here? Is it just 10? Don't forget that negative with that 10, right? Now 3 minus 2 is 1x, and then bring down minus 8, okay? What did I just do on each side? Right, subtraction. So that's subtraction property, right? Now, by the way, 1x, y'all remember 1x means what? Just regular old x from our invisible math. So the only thing I got to get rid of on the right side is this loner minus 8. What's the opposite? Plus 8. -10 plus 8. It's not 18. It's not -18. It's not even positive 2. Okay, it's -2. If you're not sure, Desmos. Okay, -2 equals, and remember, 1x is just x. Since I added on both sides, that's addition property. Now, x is by itself. It would seem that I'm done, but you want it to look like this. X equals -2. So your last step is to make sure it's x on the left side, and you know you can just flip it around, right? X equals -2. What property tells you can just flip it around? What? Starts with an S. No. So if it has symmetry, right? Because it's equal on each side, so it's the symmetric property. That was on your notes, okay? So when you just flip it, it's symmetric property. Symmetric property. Okay? Now, today, like you wrote on that blue sentence, we're going to find slope from graphs. Okay? We're going to remember stuff from Algebra 1. Algebra 1. Put that away in the phone. A what? Okay, cool. Give me that phone. LOL. Here we go. All right, folks. Oh, yeah. What's up? Después notas. All right, real quick. Rapido. Uno minuto, right? Es cierto. Here we go. All right, y'all. This should all be old news. Now, let me ask y'all a fun question. Do any of y'all remember Rady the Math Cat? Did y'all ever watch that? It's hilarious. Y'all like sock puppets? What? All right. Should I show y'all Rady the Math Cat or no? Yeah? Okay. I thought y'all would say no, so I'm kind of not ready for this, I'll be honest. All right. We'll watch it eventually. All right. I'm not ready, but okay. After the notes. Yeah, well, yeah. I don't know if I can record another video. I might get flagged for stealing or something. Oh, no.
Sir, you know you want to.
I do. I do. It's also too long. Like, I need to get through this first. All right, here we go. Rate of change, like Ratey the Math Cat will tell you later, is it's a ratio that shows how one variable changes with respect to another. And what do we call that on a graph? Slope. Slope is written as a ratio. Does everyone know a ratio is a fraction? Yo, hey, we're writing stuff down, so make sure you're writing this down. Okay, the vertical change is the rise. The horizontal change is the run. Y'all have heard of this? Rise over run. Okay, this remains constant for any 2 points on the line, and it's written as a, like I said, fraction in the simplest form. The variable for the slope is m. Now, m is nowhere in the word slope, right? That's kind of weird. So maybe you can help remember slope is m, like a mountain. It's full of slopes, okay? Slopey mountain, m, okay? Now over here, there are 4 types of slope. You can fill in the bottom part first. There's positive, there is negative, there's 0, and there is undefined. So write down those 4 types of slope, and then we're going to draw a sketch of what they look like. Now, whenever you do slope, you're thinking from left to right. So as you go to the right, positive is going to go which way? Up or down, I should say. Up. As it goes to the right, it's going up. Okay? Does that sound familiar? Upright is positive slope. So as you're going to the right, negative will go. It's going right, but up or down? Down. Okay? So positive slope is up to the right. Negative is down to the right, but they both go right. Just which way, up or down? Okay, now 0. I think of 0 as 0 effort. Like if I'm standing on this thing, it's like standing on the floor right now. Okay, just kind of 0 effort. I'm not going up a hill, I'm not going down a hill. I'm just zeroed out. Okay, so 0 is horizontal. From left to right. Okay, and then the last one, undefined. I want you to think of the word un, like you're unable to stand on it. Okay, a vertical line. Vertical. Vertical line, you cannot stand on the wall, okay, unless you got sticky shoes or superpowers, right? So horizontal 0, stand on it, that's chill. But vertical, like a wall, undefined, man, can't stand on that thing. That's it. Now let's talk about finding slope on a graph. So m is rise over run. Write that off to the left. Rise over run. And write it down here. It's always from left to right. Y'all ever seen those old school like Mario side scrollers? Okay, you're always going to the right. Always going to the right. That's how we read. Always going to the right. So in math, left to right. Okay. Now look at number 1. You can kind of like make them a little bolder. There's this point right here, and then there's this point right here. Do I start on the left or the right? Start on the left, right? In the back? Right?
No, left.
Correct. Left, correct. Okay. So now what you're gonna do is count. Y'all know what rise means? Okay. Look, whenever I think of slope, I think of like, I'm in class, I'm chilling out on the floor, right? It's a fire drill. What do I gotta do? Gotta rise. And then I'm gonna ride. Okay. Rise first, run second. Cool. Now, I'm starting on the left. Which way does it rise? It either rises up or it could rise down, okay? Which doesn't make any sense. I know, like grammatically, but we're always running right, okay? So I start on the left. Let's count the rise. Y'all with me? Look at your page or look at mine. 1, 2, 3, 4, 5, 6, 7. My rise is up 7. And then how much does it run? 1, 2, 3, 4. Okay. So, do you see using the 2 points they gave me on the grid? Okay. Now, you may have had teachers tell you the phrase pretty points, but I'm not going to say that. I'm going to just say grid points. Okay. I think we know what we mean. We're on the grid. So, 7 rise, 4 is my run. So, 7 over 4. Now, here's the deal. The only thing you want to make sure you do is make sure it's reduced. So if you just type it into Desmos, which you're allowed to use your computer, it'll reduce it for you. Okay, just saying. Okay, now number 2. Y'all see these 2 points? One right here, one right here. Which one do I start on? The left. And now this one's weird. Which way is it rising? Up or down?
They say you should do.
Seriously, the point where I'm gonna have to take it. Now, which way is this rising? Up or down? Down. How much? 1, 2, 3. Okay. Now, what kind of number goes down? Negative. So please remember, down to the right is a negative slope, so you got to have a negative sign. And then we always run to the right. 1, 2, 3, 4, 5, 6, 7, 8, 9 for my run. -3 over 9. Now, which way does it, or sorry, is that the final answer or -3 over 9? Both of these numbers look like they have a common factor. What goes into 3 and 9? 3. They can both be divided by 3. -3 divided by 3 is what? -1. And then what's 9 divided by 3? 3. So really, this is my final slope answer because it's reduced. Technically, -3 over 9 is fine, but you're going to see them reduced as answer choices. So for the special cases, what about 3? What kind of slope is that? Horizontal, 0 slope, right? Now, if you counted the rise over run, you'd have a rise of 0 over a run of 1, 2, 3, 4. 0 divided by 4 does equal 0. If 0 is on top, it's 0. Okay? But what about number 4? Vertical is what? Undefined. Now, if you were counting the rise over run, it rises 1, 2, 3, 4, 5, but it has no run. This is unacceptable. You cannot divide by 0. It's impossible. You cannot take a finite number and turn it into groups of nothing. Doesn't work. So, if it's vertical, it's undefined. Don't put a fraction with 0 on the bottom. That's like math cussing. It's vulgar. It's impossible. Okay. Now, after y'all do this backside. Yeah, well, part of the notes is the backside. So, I'm going to give you 10 minutes to do the backside, and then we're going to go over it, okay? All right, 5. You pick 2 points. You go up 5, right 3, 5 over 3. That's good. Pick 2 points. Number 6 goes down 3, right 1. That's -3. Okay. Hey. Dude.
Take your hoodie off.
No, it's not that. It's the headphone behind the hoodie. Yeah, and they're right here. That one. 4 over 2 reduces to 2. -4 over 4 reduces to -1. And
Sorry, I can't concentrate.
take it out. And then Negative 3 over 4, negative 5, 11's undefined, even if you don't have points, right? 2 over 3, 1/4. Okay. Negative 1 over 2 for number 14 because it goes down 2 over 4, reduces. And 15 is 1/3, up 1 over 3. And then you got a 0 slope because it's horizontal. When we tell that assignment, oh!
That's what I know sometimes. Well, like, check this. Check this piece of food. All right, you got one already? Yeah, I'm very crazy. What's the guy's thing? Thank you. All right. So, they're going out. All right, here in the matrix. So this is oh, so, no, this is a different. No, it's not. Yeah, there's a different one.
All right.
What's that? So can you take this actually?
You got one in the back.
Yeah.
Okay.
Yeah.
And listen. Hey. So on this, 1 through 6 is like the notes. Easy, hopefully. 7 through 12, okay, slightly spicier. What if you just have coordinate points? Now, you could, on the back, you could plot them and then count the rise over run. Or, if you remember this, slope formula from algebra 1. y2 minus y1 over x2 minus x1. You could either use the slope formula and reduce it, or you could plot them on the back. But I do want you to do 1 through 12, okay? Now, if you want to be a superstar, get some extra challenge. 13 through 15 is an extension, but right on here, 1 through 12. You want to do that now? 1 through 12? 1 through 12. Okay. Back if you need to graph. Let y'all work.